First of all, I'm sorry that I will do the presentation in English, but the truth is that if I try to do it in Spanish, it will take me twice the time, so I don't think you want to stay here like 1 hour or anything. So I will be presenting Sub10 Systems, as David said, and we are a company based, sorry, I believe that I need these. We are a company based in the UK. I should know how does it work. David, I need some help.
Try to point it to the PC, to the laptop. Closer, closer, closer.
Maybe closer. Do I have to do it like this? It works like this. Okay, so as I was saying, Sub10 Systems is a company based in the UK. And we are 100% focused on the development of millimeter wave technologies, so technologies that work in the region of the spectrum from 60 gigahertz to 80 gigahertz. The company was started with people coming from Motorola, just the colleague that was speaking before. And so they were very used to work in the wireless environment, and they just saw the need from the market to have more and more data traffic, data throughput connection through wireless. And they saw at the same time that the spectrum was full and the availability of frequencies at traditional frequencies was not high and was becoming a problem. And so they decided to move to higher frequencies, to explore the spectrum. Nowadays, we are still a private investment company. Our team of investors grew, but they are still all connected with wireless and telecommunications world. So the big commitment in Sub10 is exactly to develop point-to-point wireless links that deliver high throughput connections in the most cost-effective way. So I've been talking about millimeter bands, and now I think it is important if I explain why did we go to this direction. So the truth is that the demand for high throughput connections, as I mentioned before, and as my colleague from Motorola just explained in the best way, is growing and growing, and we talk about wireless connections of gigabit per second capacities. But so if we try to deliver that at lower frequencies, we have a problem because we need more frequency bandwidth, and as I mentioned before, the availability of the spectrum is low at the moment. Or we can also go for more complex systems with different coding methods that will be more expensive also. So we just decided to open our eyes to the full spectrum and to see, okay, we are using these traditional microwaves, but the spectrum is much bigger. So let's try to move towards other directions and see what can we deliver and produce there. So we decided to move for 60, 70, 80 gigahertz at the moment. The other big advantage, well, it can start as a disadvantage when we think that moving to higher frequencies, we have the problem of increasing the losses, but actually that can be very useful because at the same time, the costs to rent those frequencies, if there are any costs, they are much cheaper than traditional microwave frequencies. And then we have a lot of spectrum availability there, so we don't have to be concerned about the bandwidth that we use, because there's a lot to be used there, and then we can provide the high capacity throughput. So just to explain what I was saying and to say it again, traditional microwave bands, they are there in that region. The the colorful bars, they are the usual available frequencies. And then if we go to higher frequencies, we can see the availability that we have here of the spectrum. So that is exactly where we put all our efforts to develop and optimize technologies to operate in this region. Sorry that I have always to be walking here, but apparently I can't move it. So what do we offer in Sub10 Systems? One of the things that we did from the beginning is, instead of taking traditional microwave technologies and trying to improve it or change it in order to fit these higher frequencies, we developed from scratch something that was optimized for these millimeter wave frequencies. And so what we can deliver is that we have gigabit per second throughput through our point-to-point links. And as you can see in the back, there's one sample of our products, and they are really small and light, very easy to install. They use FDD multiplexing technology, so low latency that is brilliant and necessary. They are carrier class links, so that with high availability and reliability. And they also provide synchronization, Sync-E, and also IEEE 1588. So we thought not only about what are the specifications we can provide, of course that is the main goal, but then we have to think about the cost effectiveness of these solutions. And we thought not only about reducing prices for production, for manufacturing, but also thinking about the full chain, from the manufacturer to the installation, passing through the licensing costs and everything. So one of the things that I mentioned before, and that is very important and I believe interesting for integrators, is exactly the integrators and end users, is the frequency license costs that can be much smaller with these kind of technologies. The other thing is the easier installation when compared with different wireless links. And we have a special alignment bracket in the back of our small devices that make it even easier to do the installation. So you can save costs and time installing one of our links, and you don't need any technician with an incredible high skill to do this. So it's very easy to do the installation. And I've been talking about what we offer without presenting our products. And here in this slide, I have the products that we have now in the market. So we have two ranges of products. The 60 gigahertz, we have the Liberator V1000, Liberator V100. The difference is in the capacity these point-to-point wireless bridges can provide. So V1000 provides 1 gigabit per second up to 1 kilometer distance. V100 provides 100 megabits per second. Then we have in the 70-80 gigahertz, we have the Liberator E1000E, 1 gigabit per second too, and the E1000C. So as you can see there is the small form factor that I was mentioning before. The platform, the basic platform, the basic hardware is common through all the portfolio. And I will move on with other interesting and useful things that we deliver with our products and that we thought about when developing. So one of the big concerns to someone that owns a network, a wireless network, has to do with security. Our links provide high security not only because they have encryption, but also because their physical properties are also high security. And what I mean is our antennas are very directive, and because of the high dissipation, space dissipation that we have, the interference between links is very low. And to trace one of these beams is very hard because, again, we are talking about point-to-point links that use antennas that are very, very directive, and so it is very difficult for someone to jam one of our signals, right? The other thing is that all the transmission is configured in the manufacturing process, and when we ship a link, the A and B units, they are already pre-configured and they will only talk one with each other. The other thing that I believe is very important, mainly in this telecommunications business that is always changing and always asking for more and more, is that the platform we use, as I mentioned before, is a platform that is common in all our products. And it is so because the platform is very future-proof and it has a huge flexibility. So, for instance, we use DSP and we have all the flexibility to change the processing method very easily. So we don't have any ASIC devices or anything that is fully customized for that kind of product. We have a big freedom in what we can do with our hardware. Then we have 500 megabytes of memory in all of our links, and at the moment we are only using 10% of this, so that means that if the market asks for different requirements in the future, we still have room to develop a lot, keeping the same hardware, so changing only software. Talking about software, all the upgrades can be done without interrupting the system, what is very important for someone that has a network always operating. And we still have 4 channels in each of the bands that I was mentioning before that are available. So in case, even if interference is very hard and not probable to happen, even if it happens, we can always move to a different channel that is free. Okay, and now I think that the best way to show you our products is to show and talk about some real projects. And this one is with Vodafone, is a pilot project that started last year and is now just moving to a 50 links project in Amsterdam. Again, just a pilot project. They are planning to use that one as the test for implementing all around the world. The reason why they went for our solution, well, the first is we provide high throughput, the one they need. We have a very small device that can be installed in street furniture like light poles, traffic lights, or anything. Is very discreet, as you can see there. In the corner we have our link is here, so these are other devices from Vodafone, and our link is just the small thing there. And the planning of this network is very simple. We can use our links in very crowded areas, again, because antennas are very directive, there's no chance for interferences, so the planning of the network becomes suddenly very, very easy. Installation, again, very simple. And Vodafone, they were so amazed with our products that this is a photo from a Mobile World Congress last year. They asked to have one of our links in their booth, as they are there. So this is one of the projects for backhaul of small cell networks. Then the other very interesting one is a project in Russia. It is being implemented in Moscow, and we are talking about 2,600 links that are being installed in the downtown of Moscow. And this is for a surveillance and traffic controlling network. So what they are doing is they are connecting several CCTV cameras and also sensors that they have on all the controlling system of the traffic lights that they have in the city. They collect all the data and they send it back to a control building where they manage everything. So here, of course, security is one of the biggest concerns because you don't want anyone just going inside your traffic light network and doing whatever they can do with it. So they chose our products because of that reason too, beside the fact that it has the throughput they need and everything. Very easy to install again, street level installation, again, one of the biggest advantages. And we are talking about Russia, so very, very cold temperatures, and they also are more than happy with our products because they can also work perfectly at very low temperatures as they do at high temperatures. We have some links installed in Dubai, for instance, too, and they perform very, very well. So, as a last example, I have a wireless fiber business model that is an ISP. So this is in London, and what this ISP is doing is renting fiber from BT, and instead of connecting his customers with cable, they have their distribution point and they connect the new customers through our links. So they provide high throughput without having to install any cabling in the network. Well, that's for sure will reduce the time of implementation because it takes maximum 1 hour to install one of our links. Imagine the time it would take to put fiber or cable up to the customer. The other big advantage of this is that after a while, imagine that the customer wants to stop with that relationship, so he wants just to stop having this provider for the internet service. Instead of the provider, in this case Optimity, just leaving the cable there, they can take the link and connect another customer. So they can just reuse the system. Okay, I think that those were the 3 examples I wanted to show you. It was a quick presentation. I hope that it was clear enough, and I'm available for questions. I think that I can prepare for that one.
Do you have any exact idea of the cost of renting the frequencies yearly and all that stuff?
As I said, I thought that I was prepared, so
I knew it.
I have here a scenario in Europe and a scenario in Spain too. So to start with, in Europe, for 60 gigahertz band, the ETSI recommends that a light licensing mode is applied. So by light licensing mode, it is free of cost or some kind of register mechanism. So what is done in a lot of countries in Europe is that the 60 gigahertz band is totally free. And the reason why it happens at 60 gigahertz is because of the oxygen absorption, right? So that is what makes the difference between the 60 gigahertz and the 70-80. So the attenuation at 60 gigas is much higher. So these regulatory entities just think, okay, there's no chance we will have interference with this kind of link, so there's no point on having it licensed. So they recommend a light licensing method for 60. For 70, 80 gigas, the same kind of licensing that is used for traditional microwave is applied, with the biggest difference in cost that has to do with the price per megahertz. So the price per megahertz at these higher frequencies is much lower than traditional frequencies. And to give you an idea of how much lower it is in Spain, the cost per hertz can be up to 13 times lower at higher frequencies than it is at traditional frequencies. And I have in this table just some examples of the annual fee that is nowadays charged by Minitur here in Spain for the usage of these frequencies. So I have several examples with different frequencies, distances, throughputs, bandwidths, everything. We are working, as David said in the beginning, we are working with Minitur in order to have this 60 gigahertz band released too. Because at the moment Minitur is already following the recommendation from ETSI, but only partially. So what we are trying to do is to make them open this frequency and have it, the frequency is open, it is just not only free, but we are trying to make it free, as is happening already in the UK, Germany, Netherlands, and a lot of other places. So I hope I answered your question.
Perfect.
Any other question? Okay, so in that case, thank you very much, and thank you, Diode, for the invitation.